Hey everybody, welcome back to Tuesday morning after a amazing May Day long weekend. If you are an outdoorsy person, then hopefully you love this weekend because I was talking to my neighbor and we were trying to decide when was the last time we had 3 warm sunny days for a May long, and I honestly can't remember. It's been I think at least 5 years since we've had such a beautiful day, such a beautiful 3 days to get outside, go for a walk, go for a bike, just be active outdoors and enjoy the amazing weather that we had. And today is lovely as well. Tomorrow the rains come, so that's okay. We'll be working on our acid-base chemistry this week. So hopefully you've already looked at the weekly plan and you see that we are not quite finishing the chapter this week. It's a short one, Tuesday, Wednesday, Thursday. So we will be finishing early next week and then wrapping up chapter 6 and chapter 7 and chapter 8 are both short. So as I said earlier, we will be done before the official end date of the school year. Yay for that. We'll just keep motoring along. Today's lesson is pretty short and sweet. Very little calculating needed. This one is colorimetry. So using colors to measure, and it's acid-base indicators. So as you can see on my slide, I have some pictures of acid-base indicators. So this one is called litmus paper. Actually, I'm going to lie. This one is just called indicator paper, not litmus. And indicator paper does a nice job of showing us Roy G. Biv, which you know as the colors of light in the visible spectrum or in the rainbow: red, orange, yellow, green, blue, indigo, violet. It's also very useful for lots of acid-base indicators, and you can kind of see it here as well. Lots of them follow the color spectrum as they do their color changes. Now, they're useful because they change colors at very specific pHs. For example, erythrocin B is orange as long as you are around 2.2, 2.4, 2.6, and then it starts to change. And at 3, we're on the red side of the spectrum, and by 3.6, we're completely red. So we can say about this one that if you are in a pH greater than 3.6, that one is red in color. Erythrocin equals red. And if the pH is less than 2.2, then the erythrocin will be orange. And anything in between, we get an intermediate color. Now, some of them have their own unique intermediate color. For example, bromocresol green. So it is yellow at a pH of 3.8. So 3.8, it is yellow. And at 5.4, it is blue. And if we think about Roy G. Biv, how do we get from yellow to blue? There's a green intermediate color. So if you were around 5, 4.8, somewhere in here, you get this transition of a green intermediate color. So that can be helpful as well. So we're going to learn how to use these indicators to identify the pH of some solutions. A little bit of background information: where do acid-base indicators come from? Some of them are synthetic and some of them are natural. The interesting part about them, and we study this in Chem 30, is they're always a weak acid or a weak base. And in fact, all of them are a weak acid, weak base pair. So they have 2 forms and they change from one form to another. And when they do, the color change occurs. Cabbage juice is a natural indicator. Lichens, juniper shrubs, tea leaves are an acid-base indicator as well. There are lots. This example is red cabbage juice. You may have done that lab in Science 9. Lichens, which is these guys. You'll see them growing on tree trunks. So this would be a tree lichen. Whoops, I should go with the color. You can see all of these are tree lichens. And you'll see it growing on rocks as well, lichens. And when you take lichens and grind them up into a powder, you get litmus paper, and I don't have it on here. You get litmus indicator, which is one. Oh yeah, here it is. So this is one we use all the time in the lab. And it's a good general indicator of acids, which are red. I should switch this. Acids on the red side and bases on the blue side. And this one flips right around 7. So it's a really good indicator for just whether it's acidic or basic. We'll go into a little more detail than that. That's just a little background information. Here are 2 more indicators that we use in the high school lab. Bromothymol blue. And it's blue in its basic form, which is anything above around 8, 9, 10, 11, 12. And it is yellow in its acidic form, 6, 5, 4, 3, 2, and using Roy G. Biv, going from yellow to blue, we can see there's intermediate color of green. And this is right around 7 for that indicator. They aren't all like that. Phenolphthalein is an unusual one. We used it in the high school lab as well. At 8, it switches from colorless to pink. This photo doesn't really show it, but it's a nice dark pink. That's phenolphthalein. The indicators, as I said, they have 2 forms. We're just going to zoom in. Here's the phenolphthalein molecule. And this is in its acidic form. It has an acidic H plus ion. I'll put it in green right here. So this is an H plus ion. So it's the indicator with its H attached, acidic. When it loses it, so it was sitting right here, when it's gone, it's a negative ion. It's in its In minus. That H plus has left the building, and it changes the shape of the molecule. The oxygen moves around and makes a new bond, and the molecule now reflects a different color of light. And so for this molecule, we see that it is now giving us pink, whereas before in its acidic form, it was colorless. Okay, colorless and acidic, pink in its basic form. And remember, the only difference between them is the acidic has the H plus and the basic has lost the H plus. So losing a single hydrogen ion can change the shape of a molecule and change the way it reflects the color of light. So that's how they work. Okay, so let's look at some practice problems for acid-base indicators. And you will be using a data sheet, the data table on the back of your periodic table. You'll find this guy, and it has like 15 different indicators. And for each one of them, it gives us its name. It gives us its chemical formula, and this one has 4 forms. It gives us the pH range and the colors. So at a pH of 0, this one's red, and at a pH of 1, it's yellow. So what would it be at a pH of 0.5, right in the middle? Well, we're switching from red to yellow, and we use Roy G. Biv, O for orange. So at a pH of 0.5 would be its intermediate color, which for this one is orange. So most of them have intermediate colors that are stuck in the middle of this pH range. Okay, so we'll be using this table as we cruise through some examples to figure out their pH. So here we go. These are like little mystery riddles. Riddle number 1. Okay, an unknown solution was tested with several indicators. Phenolphthalein was colorless. So when we added the pink phenolphthalein to this, it turned colorless. So what does that mean? Let's go look at the slide. Phenolphthalein, right here, is colorless. So colorless means a pH of 8.2 or less. So 8.2 or lower. So what I'm going to do is a little pH bar here. And I am going to put that it is below 8.2. When it catches up, it decides to let me draw 8.2 or less on our pH scale. So we know it's somewhere between 8.2 or less. Okay. Bromothymol blue was blue. So let's go back and look at bromothymol blue. It's right here. Bromothymol blue is blue. So blue is on the right side, so that means 7.6 or higher. So we go back here. So we know on this side it's 7.6 or higher. So now we've narrowed it down to a pH of between 7.6 and 8.2. We have one more clue. Phenol red is red. Okay, so let's go take a look at that. Phenol red is red. Okay, here's phenol red. And red is on the right side, so that's this number. So greater than 8.0. Okay, so now we also know that it is greater than 8.0. So I'll estimate that to be about there, 8.0, and I'll put the arrow going greater than. So on our scale, we are less than 8.2, greater than 7.6, greater than 8.2. So these are the two bars that we are interested in. Greater than 8, less than 8.2. So you can either figure that out in your head or add them together and divide by 2 to get the average of 8.1. So pH, I'm going to teach you a new sign today. I don't think you've seen this one before. This is a squiggly equals sign, which means approximately 8.1. Okay, so there's the estimated pH or approximate. And what's the hydronium ion concentration? Concentration of H3O plus. From the formulas you learned before the break, you go 10 to the negative pH. So on your calculator, that's the second log key. And that will give you 10 to the negative. And then you'd put in the negative 8.1. Second log gives you 10 to the x. Okay, 10 to the negative 8.1, which equals 7.94 times 10 to the negative 9. Okay, almost done. We just got to figure out sig digs. So this is a pH number. So on pH is only after the decimal place. So 1 sig dig. So on my hydrogen concentration, H3O plus or H plus, I forgot that we use this one as well in Chem 20. They're the same thing. Chem 30, we call this H3O plus or hydronium, and in Chem 20, we call it the H plus ion. Same thing. Okay, so 1 sig dig. So I need to take this number and turn it into 1 sig dig. So it's not decimal places anymore because it's a normal concentration in moles per liter. So 1 sig dig becomes 8 times 10 to the negative 9 moles per liter is the concentration of H plus. Okay, so that's the skill, ladies and gentlemen. We'll try one more. Example number 2. Separate solutions of an unknown solution were individually tested with several indicators. What is the most likely pH of the solution? Okay, so methyl red turned red. So we got that result, not yellow. So methyl red turned red. Okay, I'm going to jump back. Methyl red is red. So on our table, here's methyl red. Turned red. So that's the left side. So the left side is 4.8 or less. Okay, 4.8 or less. So I'm going to do my little pH line here. Whoops, on this side, 4.8 or less. That's what methyl red will do when it's red in color. Okay, next one. Thymol blue is yellow. So here's our thymol blue, and it's on the yellow side. So let's go look up thymol blue. You can look on your own acid-base table if you want. Thymol blue is yellow. Okay, here's thymol blue. It's yellow below 8 and stays yellow above 2.8. So above 2.8 and below 8. This is a tricky one because it's got 4 different forms. So it turns yellow above 2.8 and turns yellow below 8. So let's go back down and see how that works. Well, we already know it's below 4.8, so that below 8 doesn't really help us, but the above 2.8 does. That's going to help us. We know it's below 4.8, and now we know it's above 2.8. Our last piece of information, methyl orange turns red. This one, methyl orange is red. Okay, methyl orange is red. So methyl orange is right here, and it turns red on the left, and red means below 3.2. Below 3.2. Okay, so that means somewhere in the middle here. 3.2 and below. So our final two lines that will help us are above 2.8 and below 3.2. So 2.8 plus 3.2, I'm getting the average or the middle of it, divided by 2 is 3.0. Interesting. Okay, I'll just verify that. Methyl orange is red. Methyl orange is red above 3.2. Yep. Okay, so our pH is 3.0 exactly. Well, that's easy. pH is approximately 3.0. Concentration of hydrogen ions is 10 to the negative pH, or 10 to the negative 3.0. When you put that in your calculator, you get 1.0 times 10 to the minus 3 moles per liter. Done. Okay, that was easy. Now, there are 3 more examples. I don't think these are in your notes. So you can try A and B and C, all 3 or one of the 3. If you get the first one right, you don't need to do the second. If you get it wrong, try the second. These are the 3 questions. And then I have the 3 answers on the next slide. So you can pause here, try the first one, figure out the pH, and then check below, and then do the second one. If you're still needing more practice, do the third one. And then this slide has all of the answers. Okay, shrink that down a bit more so you can see them all. So there are your answers. So I'll go back up here and leave it on this one, and then you can rewind, fast forward the video to check your answers as you go. Okay, and then your final assignment for additional practice is in your textbook, page 247. There are 3 questions, numbers 1 to 3, that you can work on in the text, and you're good to go. A nice short lesson today and a short week. We only have Tuesday, Wednesday, Thursday. Friday, there are no classes for any grades because it's our grade 12 grad. Okay, have a nice day, everybody. We'll see you guys tomorrow.